Our cousin was so happy with what we did with her analgesic tablets that she sent us another package. But this time it's not paracetamol tablets. Instead she sent us some piracetam instead. Piracetam is an unusual molecule as you can see here, and we'll talk a bit more about it later on in the video. Well, we were trying to think of what to do with it, and the most interesting first thing we could think of was to see if we could perform the double hydrolysis of the two amine groups in the molecule. So let's have a go and see if we can get a pure product. She's sent us 12 tablets and each one contains 800 milligrams of piracetam, so that's 9.6 grams in total. First let's get these crushed up so we can get them into a solution. Okay, this is looking nice and fine now. The crushed tablets weigh 10.1 grams, so there's only half a gram of impurities in here, which is great. Let's get the powder onto the hot plate stirrer and we'll get a magnetic stir bar into the beaker as well. Piracetam is very soluble in water, so we'll use water and see if we can get this into aqueous solution. With a bit of luck the tablet binders and impurities will be insoluble. We'll start off with 40 ml and see how we go. It looks like a lot of the powder is going into solution, but it's cloudy and there's some yellow insoluble stuff in there as well. We put a thermometer in so we can record the temperature. Our nice electronic one has broken, so we're back on mercury technology now. We'll heat the mixture gently just to give the best chance of the piracetam dissolving. We'll just let this slowly increase and see how it goes for a few minutes. While this is happening, let's have a closer look at piracetam. Piracetam is what is known as a nootropic drug. It seems to have a mild effect of increasing awareness and concentration and has actually been used to treat cognitive problems including dementia. It's also very popular with students to help them study, but we can't confirm if this is a good idea or not. What is interesting though is that no one really knows how it works. But if we look at the molecule and compare it with some other compounds we can see it's quite similar to GABA or gamma-aminobutyric acid, one of the most important neurotransmitters in the brain. GABA is what's known as an inhibitory neurotransmitter. Too much of it and very simply your system shuts down. This is the indirect effect of drugs such as alcohol, benzodiazepines such as Valium, gamma-butyrolactone known as GBL. And too little of it and your system becomes overexcited. Some dangerous poisons such as strychnine and EETS have this effect and the result is convulsions and death. Very unpleasant. Other compounds such as gabapentin and pregabalin mimic the neurotransmitter in the body and have powerful neuropain-killing effects. So there are many compounds which have an effect on this system in the body and their effects are very diverse and complex. It's a fascinating area of research. Well, as you can see, it looks like there's some undissolved solid in here, so we'll add another 10 ml of water to make sure we've got everything we can out. And we heat it up to about 55 degrees C to increase solubility. So while the mixture is hot, let's set up to filter it. Well, it looks like those tablet binders are just the right size to block our center, so we had to switch over to using a paper filter. It still flowed, but a bit better now and we can wait for this to filter through. Here's our milky looking filtrate. There wasn't much left on the filter paper, so it looks like we've got most of our piracetam into aqueous solution here successfully. We first chilled this down to see if we could get any crystals to form. But even after a few hours of chilling, there's nothing forming. It's just too soluble in water, so we'll try a different tactic. Piracetam is not very soluble in ethanol, so we'll add some absolute ethanol to the mixture and see if this can precipitate it out. Here's about 40 ml of ethanol. Let's add the filtrate. And there's no solid forming. In fact, we chilled this mixture down in the freezer for a few hours and the result was still the milky colored solution. No crystals or precipitate. It looks like it's just too soluble to precipitate out. This is okay. We'll go ahead with our amide hydrolysis reaction using the solution here in water and ethanol. So we weighed out some solid potassium hydroxide. We need to hydrolyze two amide groups in each molecule, one being the ring and the other being the acetamide. So to make sure this completes efficiently, we'll use 3 mole equivalents of potassium hydroxide. This is 11.4 grams. Let's get our piracetam solution on the hot plate and add a magnetic stir bar. And let's chuck in the potassium hydroxide. In the ethanol and water it dissolves literally in seconds. So now we're just going to heat the mixture up. The hydrolysis should take place quite easily with a bit of heat. And very quickly we've got ammonia gas coming off, as you can see from the alkaline reaction on the indicator paper. This is the byproduct of the acetamide group hydrolysis taking place. We'll leave this now with enough heat to slowly evaporate off all the ethanol we put in earlier, and until we detect no more ammonia gas coming off. And here we are 2.5 hours later. The volume has reduced right down, as you can see. There's still a very faint bit of ammonia coming off, so we keep heating and stirring for another hour. Okay, so 3.5 hours in total. There's not even the slightest hint of ammonia present. So we're hoping now that both our amide groups in the molecule have been hydrolyzed and that we've got the double potassium carboxylic acid salt in solution. We let the mixture cool down and then chilled it down in the fridge, ready for the next step. We're now going to add concentrated hydrochloric acid to the mixture in order to convert the potassium salt back to the double carboxylic acid. We'll also need to neutralize any excess potassium hydroxide present. So here's 15 ml of concentrated hydrochloric acid, which is approximately the right amount. So let's add this to the mixture. There is, however, a catch. If we add too much hydrochloric acid, we'll protonate the amine group in our product and form a different type of salt. To stand a chance of extracting the product, we need the free amino acid, so we need to watch the pH carefully. Still strongly alkali, so we need to add more acid. This is now slightly on the acid side. We actually have no information about the product and at what pH it's in the free amino acid form, but we're going to guess it's about 8. So we make up a little sodium hydroxide solution, and add this dropwise to the mixture and carefully adjust the pH back down to around 8. Okay, here we go. Let's try this and see what we get. We set up a Pyrex evaporating dish on a hot plate, and then pour in the mixture. and now on a low heat over a few hours we let this evaporate down until the water is gone. There's some nice crystals of potassium chloride forming in there at little squares. We break up the crystals and allow to dry completely. Here we go. Square-shaped potassium chloride crystals, and also some white powder as well. So now we're going to use absolute ethanol to see if this will extract our product, but leave the potassium chloride behind, which should be insoluble. Here's 40 ml. Let's give it a quick nuke to help extract as much as we can. Let's get this into a beaker. And now let's filter this to remove the insoluble salts. Our center is obviously a bit dirty as it's turning our filtrate slightly yellow, but it's nice and clear. And now we'll evaporate down the ethanol from the filtrate, again on a hot plate, and see what we get. Here we go. It's an off-white solid with a slightly waxy consistency, as you can see. So here's the product. 6.3 grams, and we strongly suspect that this is our double amino acid with a secondary amine group and two carboxylic acid chains coming off, one acetic and one butyric. You could probably test this via titration, and via tests for secondary amines, but we'll maybe do this in a future video if we find a use for it. The yield of the product compared to the theoretical starting tablet content is 60%. Not bad. There's probably still a bit of product left in the solids if we wanted to perform a second extraction, but we'll leave this as it is. So there we go. An interesting dicarboxylic amino acid, prepared by the hydrolysis of piracetam tablets. Don't ask us if this has any medicinal effect. We really have no idea, and we're not about to taste it and find out. It seems very unlikely though. Thanks for watching and stay tuned for more reactions.